Thank you, Ashlyn, for invitation. Thank you for being here today. My topic is about underground freight transportation mobility in Texas. This is a project we conducted for Texas Department of Transportation, and we just completed last December the final report, which is about 220 pages. However, we have a summary on the table. You can pick up the summary and the website that you can download the whole report from the website. So again, this is text project 06870. We started about this time in 2015, and as I said, we completed final report in December 2016. So the outline for my presentation today, I will give you the acknowledgements and some introduction, and then we have 6 tasks that I go through each one of them. We talk about the objectives, methodology, results, and summary of each task, and they give you some of the benefits of underground freight transportation. So with that, okay, thank you. Just wanted to give some acknowledgements to the Texas Department of Transportation. Our project manager was Chris Glancy, and we had a technical review board. I don't go through the names, but you can see on the screen. And also we had some help from DOT and some other TxDOT engineers who provided information. Also, I would like to acknowledge my co-principal investigators, Dr. Ardekani and Dr. Shandashti. We had also a number of graduate students who helped us on this project. Amir Tabesh, who is here today, is one of the PhD students, and we appreciate all their hard work. So basically, when we talk about freight, we are looking at railroad, we are looking at airlines, trains, and trucks, basically. The trucks are the primary mode of transportation for freight. You know, if you want to ship something from one location to another location, the fastest way to do it is using a truck. And so the trucks contribute to a lot of congestion on the highways. They produce a lot of air pollution, emissions, and accidents, and they damage highways and bridges. So basically, and then you need to consider the expansion in future, the volume of freight coming from China and the trade from other countries that are used by trucks to ship. So in order to reduce the impacts or the negative impacts of this mode of transportation, the underground freight might be an option. Looking at the ports in the US, we have Port of Houston, which is one of the primary ports next to LA and New York. Actually, if you look at the tonnage for the Port of Houston, it exceeds New York and Los Angeles. If you look at the dollar value, Port of Houston is less than the other two. But in any case, it is one of the major ports in the US, and as you know, the cargo comes from Houston to Dallas, and also to the Mexico through Highway 35 to the border to Mexico. So what we talk about underground freight, we are looking at individual vehicles that are automated. They go from intermodal terminals and underground, and they ship the freight without any surface disruptions and producing any type of negative impacts. Looking at the intermodal nature of UFT, if you look at cargo coming through ports, then possibly goes through the 18-wheeler trucks or maybe through train, and then goes inside the city and then distributed by smaller trucks. What we are proposing is coming from the port, going to underground freight transportation. So we want to reduce as much as possible the 18-wheelers on the highways, and then bring it to the terminals at the cities and then distribute it by smaller trucks. So this way, it has actually benefits to the drivers as well. They don't have to be away from their families for a week or 10 days. And on the other hand, we reduce the accidents and other negative impacts of the truck delivery. As you see on the schedule here, we had several technical memorandums and reports and meetings that we held. And so this schedule is the way each task was done and eventually was completed in December. So again, looking at UFT design, the way we came up after our research was having a tunnel or pipeline, and then the two tracks, such as railroads, and then we have these driverless vehicles that can be three sizes for pallets, containers, and crates. And as you can see, the propulsion system is linear induction motors at the bottom, which is very efficient and uses electricity to move these vehicles. So our task one was planning and design. The objective was to come up with a schematic of the vehicles and the tunnels or pipelines. And then also we developed the design equations for the LIM system in order to provide enough propulsion for the vehicles. So basically we did operational parameters. We calculated the head base capacities and the loads and the power system requirements. We actually consulted with LIM engineer in California who helped us doing this. So the design of the vehicles were for crate and pallets, we considered capsules. And then for the container size that comes from other countries, we considered just flatbeds or gondolas. So we had two types of vehicles basically, and we considered, load stillage and other things for moving the freight. As you can see on the slide, on the right-hand side, we considered a single track for like two parallel tunnels, and on the left side, we considered dual track. And then we came up with all the measurements and the diameters and the size of the vehicle inside, and then some of the utilities that are required for movement of this freight. So the one I showed you here is the container or the largest size. Here is the crate, which is the medium size, and again we considered both options. And then the pallet size, which is the smallest size, and again we considered single track and dual track. Eventually, talking to engineers and contractors, they said, if you go dual track for all of them, would be less costly and more efficient for construction of the tunnel. So for all of them, we considered dual track. So on the right, you can see the pallet, and the middle is the crate, and the left is the container size. So we also looked at the GIS map for the route from Houston to Dallas, and we came up with all the obstacles, railroad crossings, and any type of bridges and everything else on the highway that requires attention. We proposed the concept after a lot of investigation, maybe considering using elevators, bringing the freight from underground to terminal. We considered the slope. So after talking to the LIM experts, they mentioned that LIM can have a capacity of moving the freight, maybe even 10%, 15% slope, coming from underground to the terminal. So that's the way we chose, and then we came up with a design for the terminal. As you can see, the vehicles come from the tracks underground, and then come to the terminal, and they can get unloaded, and the freight can be stacked on the side, and eventually the trucks come and pick them up for distribution. So the results for this task, which is planning and design, is given here, and we considered for Houston to Dallas around 3,000 containers on each way can be shipped. And then for the crate and pallet, around 4,300 vehicles can ship the freight. And then, of course, we need to have a number of forklifts and handlers at the terminals. And you can see the weights, like for the container is 34 tons, and the crate is 3.5, and the pallet is 2.3. So the summary for this task, we considered 3 sizes. Also, we considered a route from Port of Houston to a satellite station outside of the city in Baytown. That was one of the routes we considered. And then another one was the border with Mexico at Laredo. As you know, it is very congested. So we thought maybe the crossing can go through the underground freight. So for the construction, we considered open cut or cut and cover, and using pipelines. And also we consider different modes of doing trenching and building those tunnels underground. For open cut, we considered the height or the depth from the ground surface to be about 5 feet to top of the pipe, so it's very shallow. But for tunnel, is around 50 feet deep. As you can see, there are a number of construction methods, and we looked at trenchless technologies and tunneling for the areas that open cut may not be possible. So for tunneling, we considered shaft locations, shaft area, and other factors. So as you can see over here, we have every 1 mile, we have an access shaft for the UFT, and then for building the tunnel, maybe about every 10 miles, we have entry exit shaft for the tunnel construction. We also considered building the shaft sloped like this. That has been done in some other countries, so that is another possibility. We looked at different wall supports for the shaft, so we went into a lot of details. We looked at Highway 45, we looked at the maps and saw where the open cut is possible and where we need to do tunneling. So for open cut, we considered putting 2 precast concrete pipe like this, and have the trench sloped for safety. And then we talked to Forterra about building those pipes at the site. So we reduced the transportation. So as you can see, for the Houston to Dallas, we have 100 miles of open cut or cut and cover, and then 150 miles of tunneling. So from Port of Houston, we'll be tunneling up to Corsicana, and then when we get near Dallas, about 50 miles to Dallas, we get tunneling as well. So in the middle section, as you can see, Huntsville to Corsicana, we can have open cut, possibly. For the Laredo border, we couldn't have open cut due to river and all the congestion on the surface, so we had to pick the tunneling option. And then from Port of Houston to a satellite at Baytown, we had to do tunneling because of the urban areas in Houston. So again, these are some of the assumptions we made for the construction for open cut and tunneling. And then eventually for the summary, you can see that we even came up with number of TBMs, tunnel boring machines, and number of excavators, number of contractors. Maybe each contractor can do 25 miles or something like that. For the cost, we looked at all the parameters which includes in the underground freight. Basically terminals, vehicles, LIMs, and energy consumption. So we came up with the life cycle cost of the operation and including the capital cost. We got quotes from industry, we looked at RS means cost data, and then for each parameter, like for tunneling, as you can see, for the shipping container, we had around $9,000 per foot, and then the crates about $6,000, and the pallets around $4,000 per foot. And then also we calculated the cut and cover cost to become $1,000 per foot. However, this doesn't include cost of the pipe. Forterra said the pipe will cost $5,000 per foot. So that's going to be similar to tunneling. So we consider cost of the tracks. We are having steel wheels and tracks similar to railroads. And then we have $1,000 per actually $1 million per mile in 2016 dollars for the cost of the track. And then we have concrete bedding under the tracks, and then we calculated that as well. And then we calculated the cost of the vehicles for crate, pallet, and the container, as you can see on the right-hand side. I'm sorry I have to go through this very fast, but hopefully you can catch more information on the report. And then the LIMs also, we came up with some estimation of the cost. That was $500,000 per mile. We estimated every 500 foot, we have one LIM. And that would be sufficient for even the container size. So as you can see, the terminal cost is also estimated, and we looked at the land cost for that. And the energy consumption is very efficient, is maintenance free, basically, for LIM. And as you can see, the cost of the consumption. And also we looked at the people who work at the terminals and how much are their salaries and how many people, supervisors, operators, inspectors, and we came up with their costs. And then we came up with the annual operation and maintenance costs. Basically, LIM and the tunnel does not have that much maintenance. However, some other electronics and computers and other facilities, they have maintenance. And then capital cost, As you can see, for each of the routes, Laredo, Houston to Dallas, Houston to Bayton, for three options of crate, pallet, and the container, you can see the costs are calculated on the right-hand side. However, this cost is in millions of dollars. So from Houston to Dallas would be around $13 billion. And this is a lot less than the wall that they're gonna build for them. It seems very high, but so we also looked at environmental impacts. So far, the cost was direct cost. We didn't look at the social cost and the environmental impacts. So actually, Amir did this task, who is here today, and we evaluated the advantages and limitations of UFT. Considering UFT using electricity and possibly using solar energy or wind energy, we have very environmentally friendly production of the energy. So we don't have that much air pollution, we don't have noise and water pollution, we don't have traffic on the highways. You know, the main traffic source and the slowdown on the highways are the trucks that they go about 50 miles per hour when loaded, and then accidents, fatalities actually caused by trucks, most of them, and so this and then damage to pavement and the bridges caused by trucks, and security also. Trucks are very easy for people to rob, during the night when the drivers are sleeping, or used for terrorist attacks and other things. And then consumption of fuel and other things need to be considered. And then you need to have a reliable freight transportation no matter what the weather conditions is. Is this no tornado or other impacts, ice or anything like that? We don't have any impacts on underground freight. And the land use, there is an estimate on this summary that I handed out that it says for 200 feet right of way of the highway, you have to use 24 acres of land. And land is a resource. And then you look at Dallas, Houston. If you go, driving, you see that most of it is building, become urban. So we need to save the land, and this is one way to do it. And then operation and maintenance cost is less, and then life cycle cost is less. Then there are some issues, some people say the drivers may lose their job, or some localities may lose the tax revenue, or truck stops maybe lose their business. There are some switching of business with or income with underground freight, but then the jobs are more friendly to people and less stressful for the drivers. So as you can see, it is calculated based on this concept, and then we came with dollar per ton mile based on this figure, as you can see, and we look at positive impact, negative impact, and then we put dollar value for each parameter, and then net impact benefit is about 2 cents at the bottom of the table. And then if you consider the annual benefit, and then I give you an example for 250 miles from Dallas to Houston, it becomes around $400 million per year. That would be the benefit that you need to consider into your life cycle cost. So the alternatives, when you look at the future, 20 years from now, 25 years from now, either you need to expand or widen the highways or build new ones, or you need to do nothing and face the congestion and possible future or use something similar to UFT. So in summary for this task, it reduces social cost, environmental cost. Government agencies may lose some fuel tax and other things, but they may get some other types of income. And then we looked at financial means. We look at the sources that might be possible, public-private partnerships. To do that, we looked at several highways that were built in Texas. And we considered, as you can see on top of the table, you see the highway. And then on the left side, you see the type of sources of fund. So a mix of private and government funding might be available, and different types of delivery methods, and so it is something that is doable. And then we looked at cash flow analysis, we look at the net present worth, we look at benefit cost ratio and the rate of return. And then we look at all of these for different 3 routes that I told you about, and also different sizes. So as you can see on this table, we considered the environmental impacts as well in our cost calculation, and also the this is the Port of Houston we considered Lancaster, south of Dallas, to be used for a terminal just before we get to Dallas. So that is the type of cost that is calculated for benefit cost analysis. And then in summary, you can see the benefit cost ratio here. And it is also in the summary I handed out. And the internal rate of return on the right-hand side, and the net present worth is this column over here. And then also we have it for all sizes and all the routes that we considered. The last task was basically a stakeholder. We invited Federal Express, UPS, Walmart, Amazon. Unfortunately, none of them participated, but but the truck companies, one of them attended the meeting, and also we had the truck association, we had the railroad company who attended, and some of the cities participated. So we had a stakeholder committee that was formed, and we, as you can see, the categories are given in this pie chart, and then we went through some type of brainstorming and asked them, whether this is a good way to do this or not. And most of them, actually, as you can see, they thought the project is needed within next 25 years. And then some of them thought the short haul distance is preferred. However, in our cost analysis, from Houston to Dallas is more cost effective, actually, than if you go short distances for UFT. So this is something we need to investigate further. And then these are the 10 major issues they came up with in the stakeholder. And overall, the image was very positive, and they were very supportive. And then just to give you a comparison, again, just to conclude, you can see the length of each of those highways, like LBJ Express. It is 3.1 billion total cost, and is about 194 million per mile. So when we started this project, everybody, or maybe some people, were saying never is going to happen. It's going to cost billions of dollars. But you are already paying for highways, and they cost similar amount of money. So, and then highways, every 20 years you have to maintain it. The pavement needs to be resurfaced or redone, and the bridges need to be maintained. You need to consider all of those when you are building highways. And so just give you a comparison, if you are in urban or rural, maybe rural is less. Highway is about $55 million per mile. In the city, urban is about $147 per mile. For UFT, it doesn't matter if you go in the city or out of city. If you do tunneling, it's around $53 million per mile. So it's comparable, it's not out of line. And again, if there's, you are in the urban environment, sometimes there is no more room to build more highways. And then you need to consider the noise and dust and pollution and everything else. So basically, overall, positive results, and we are hopeful to go to phase 2 and phase 3 to do further investigations and also do a pilot project. With that, I would like to show a little animation that tells you how everything works, and then I'll be available to answer questions. So as you can see, the terminal is outside of the city, and the trucks come and pick up the load. And we are not using any more land. We are going under the highway. And technically, it's possible. We talked to tunneling contractors. They were all positive. The soil conditions in Texas are suitable for tunneling. And also we talked to Bombardier at the airport, and they are also manufacturing LIM. They were very supportive of this type of technology, and if everything is doable, it just needs to be further investigated. And with that, I conclude. And any questions?